Again, I'm making very short things. Pre-attentive datagrams are the one which said short listing. Pre-attentive is before you select, before you prioritize, which we mentioned, we give priority to things that to see, understand it. This is computer automatically shortlist things for you. Pre-attentive datagrams do not have relationships with each other, so they do not have relationship with, so they do not have context attributes, only dimensional and distribution ones. Okay, a bit technical thing, it doesn't matter. When the change points of 2 points meet in the same pixel, we interpret this as causation. Okay, so on the pre-attentive point is that they are basic things. They come, but they, first of all, they don't remain in our short memory, but they get shortlisted. But we have to fix them together to understand what's happening now, to use their ingredients, in fact. We use those ingredients to understand what is happening now, and when we understood it, we automatically registered new datagram and we put it in long-term memory. Causation, what caused the other one, is if any edge moves the same time, the same place of another pixel. If we speak on the pixel. So any pixel move together and the same time and the same place, we consider them, one of them, to be cause of the other one. So it's another definition, which mainly we don't need it, but sometimes when we want to make in our visual, again, in understanding, yes, if we want to understand things like artificial intelligence, we should understand that what caused what, who is the subject and which one is the object, for example, in a sentence. So because object is always one who changes the subject, is the cause of the subject, changing the subject. So in this case, when it happened, these two things move together in the visual, but any change in general terms, any change happens together at the same time. This is causation. Another point is when we have this subject with these concepts, we make class of them. It's a categorization. So we have, for example, dog, cat, and we put these two, dog, cat, become animal, and animals and plants, they become things, and things, well, it's more general, but it can be also, we can consider tangible things and idea abstract and become another thing, we can call it. So always we have different levels of classification. And key class is the one which is important to give us that classification from top to the subclass. So in order to understand things, we have to have always from top what is thing, what is existence, and this exists, and then we have these animals, we have cosmos, we have matter, and we have animal, we have different type of animals, and then we have dog and cat and this sort of. So it's a things, all subclasses that tell us what a thing is. If we want to understand something, we have to know what it contains, what it covers. If we want to understand cosmos, universe, we have to know everything which is in that universe. So understand, okay, understood it. But if we want to know wood, we have to know what the wood can cover and become subclass to the wood, and all together. So we record new information as a supplementary subclass of an existing key class, but we only record new information in long-term memory if we have attended it. So things does not automatically happen. We have to make attended it. We have to shortlist, bring it, and create idea out of it. there is possibility, strong possibility, that what is called REM sleep, REM is R-E-M, rapid eye movement. When we, at night, we see things, is in fact, it's, there is, anyhow, because it's not related, I don't elaborate more, but there are evidence that to show that our mind makes a lot of what if situations. What happens if this happens? So from the information we learn in the day, at night, it creates, with other information we had before, new stories, new situations. And it's, in fact, virtually creates new possibilities and checks it. If happens this, what happens that? And by this, new ideas get registered, yes. So attention is not always means that we conscious of it. Maybe it happened, we are dreaming. That also part of the attentive. And in computer we call it self-learning. The computer can learn automatically by itself. It can run software, for example, in games. They make two players, one play against another player. It's the same computer, but they only change one rule, and to see if this rule can win or not. If wins, so that rule becomes a good rule, and they use it next time. If no, they drop it and they make another rule. So these are the ways they do it in computer. In our life, we use this REM sleep to do that. Here it says that we have this class and subclasses, so every subject is somehow related. Tracking attributes deliver sensations such as intent, failure, and successful completion. When we have some idea as a figure comes into attention, in our physical world, we call it sense. We sense it. This is glass. When I attend it becomes sense. I was using it, but I didn't sense it. But when my attention comes to it, I sense it. It's there. Yeah, okay, I understand it's there. So in computer, the sense, we don't have sense really in computer, but we can create it by giving attention. That automatically is the same as sense. Tracking this sense, tracking this attribution is like intent and failure and successful. So if we track it and see what happened to it, it becomes these sort of ideas which we are using in emotion really. That what we wanted to do and did we succeeded or not. This is another point in that. To make it things again simple to understand, so the class, when we say, sometimes we use concept, the word concept, it depends on different words. They use it just not to mix them between what human uses and computer uses. They put two different words for computer and for human, just not to mix things. Otherwise, it's not the same. So if we have a blue area, we call it red, and we have a red area, we call it flowers. What is in the middle? The brown one, which is somehow
combination of.
Yeah, what we call it? We call it red flower. In there. So so if we had a living room, we have now three more areas. The one with the red, between blue and red, what becomes?
Blue and red.
Yeah.
The flowers in the living room.
Flowers in the living room. And the blue and green?
Blue and green, the red things in the living room.
Red things in the living room, and the one which is, okay, the brown on top we said about it is red flowers, and all three.
The red flowers
the red flowers in the living room. Okay, in computer when it comes, we say we have these concepts, red flower and sitting room, but for example in this book, it insists that we can have only two parents, only two connections from top to, so we can't have three. So if we wanted to have the middle one, which is 3, what we had to do, we have several ways of doing it. We could have red and flower to become red flower, and with sitting room become red flowers in sitting room, or we could have sitting room and red, so anything red in the sitting room, then plus flower become red flower in the sitting room, and or we could have sitting room and flowers, so all flowers in the sitting room plus red become red flowers in the sitting room. So when we put a rule, because of binary, it's easy to have only 2 parents. It uses this, and I just wanted to give, if we can't have 3, we can have 2, but with different intermediary layer. Now, again, as just final thing, as example, we want to say sentence. If we want to have sentence, here probably deaf people are better, because that's the way they use it. It's a word, and just by location, not necessarily grammar, not necessarily grammar to use it. So if we have one column, always objects, we put them in that column, and subject we put in second column, and verb in second, third, and time in the fourth. You tell me what was first line in our sentencing, what we say, or what does it say, the first one. The
The dog bites the man.
You see, that's a problem. No.
Oh, you have to read the...
Yes,
the
subject is it. Yes.
Man with the dog bites...
No, that was right. Man bites the dog, not dog bites the man. You see, that's a problem. We, as a human, we see it that man bites dog, but we say, no, that doesn't make sense. So it should be wrong. You correct it. So you automatically corrected what was there. But no, we should always see what is there, and then use artificial intelligence. Say, that doesn't happen in our statistics. That doesn't happen, that man bites dog. So it should be wrong. So we corrected it. It's important. The second sentence?
Dog chases the cat.
No, past the time. You forgot to see the time.
Oh. Okay. So the dog chased the cat.
Yes. So that's the second sentence. Dog chases. Third one?
The cat will jump over the car.
You see, it could be under the car. It could be next to the car. Its information is not there. So you added the over because that's the statistically most possible case.
Way of jumping.
Way of making sense of this sentence. No. That's what happens most of the time. Not beneath it, not side of it. So that's another aspect. So as a sentence, we can understand the sentence, but limited. I mean, the formation could be other, it can have several meanings, several possibilities. You just put more weight on different possibilities. And over gets the maximum, so you use it automatically. That's intelligence. It's not something difficult. That's the way it works. And the last one, oh, sorry, the jump was wrong. It's a future. So your sentence was wrong.
No, I said...
What did you say?
I said the cat will jump.
Will jump, yes.
Yeah.
Will jump, yes. Could be over car, next to car, in front of the car. It could be in front of the car, quite possible. So, okay. Then the last one.
The car drove over the man.
Drove, again, over the man, or, yes, beneath the man, or whatever. It can be beside the man. Because here, that sort of information is lacking.